I'm sharing my screen. Let me know if it is visible or not. Ask your friends. Join the class. Shear. Give a message. So we'll discuss shear force and bending moment diagrams. Okay. We have discussed the theory part. Importance of shear force and bending moment diagram. Right. We discussed some problems also. Now we'll discuss the problem with two loads. One type of load will be UTL and another will be point load. Okay. Let others join. So clearly see the till rest of the students join our class. See the question. A cantilever beam is given with UTL over the whole span, right? And two point loads are given, one of 1 kilonewton and 5 kilonewton at a distance of 0.5 meter from the fixed end. This 1 kilonewton, let me know. Just give me a minute. This 1 kilometer is at a distance of 0.5 meter from the fixed end, and this 5 kilonewton is at 1 meter distance from the fixed end. So from here to here it will be 1 meter, and this is at 0.5 meter distance from this point of 1 kilometer. And this UDL of 2 kilonewton per meter is spanning over the whole span. Okay. Before start, let's see. What happened to others? I love the meeting. Ask CR, ask them to join soon. Those who know how to solve, try to solve by yourself. Okay, let's start the class. Screen is visible, right? Okay. Okay. Let's see. Since the cantilever beam is given with UDL and point load. So what we'll do, we'll first let's take a section of XX from the free end. Okay, we'll take a section here, we'll take a section here, and we are taking three sections. This one between D and B, then between B and C, and then C to A. So when I let's start with this section XX at a distance of X from B. So consider a section XX dash at a distance X from B. Shear force between BB. Let's find the shear force between this B and D by considering a section of X1. So shear force. So if you see in this section, what will be the shear force? Usually we take for point load we take 5 kilonewton as shear force, but we have UDL. So in the case of UDL, the shear force will be W into X. Okay, because this is C kilonewton per meter, right? So it will be W into X. Then I'll get shear C. The unit of shear force is kilonewton, right? My this value W is your kilonewton per meter. If I don't multiply X, X means X is in distance. Meter. So this meter will cancel. I'll get the value in kilometer. That's why we do multiply. We used to multiply load with the distance in the case of UTL. So it will be W into X. Clear? So shear force will be W into X. Now place the boundary condition, that is at X equals to 0. At here it will be X equals to 0. Here it will be at X equals to 1 meter, because the distance is 1 meter. So when I place at X equals to 0, my shear force at B will become 0. And at X equals to 1 meter, that means shear force at the D point, it will become, load is 2, distance is 1, so it will be 2. Understood this part? The shear force at, I've taken a section between these two parts. I found out the shear force equation and placed the boundary condition find out the shear force. Hope this part is clear. Now let's take the new section, which is shear force between D and C. So now I'm shifting my section. Now I'm considering section at this position. So just assume that you are considering a section, and in this section you have a UTL over the whole span of 2 kilonewton 2 kilonewton per meter, and there is a one point load of 5 kilonewton, and this distance is 1 meter, and I have considered this section as a x meter distance. Okay, so what will be the shear force for this? So shear force will be W into X. I'm taking the downward direction as positive, so it will be 5. W into X, due to this UTL, what will be my shear force? W into X plus, due to this point load, my shear force will be 5. Clear this part? This equation is clear? See, don't tell me to explain the whole question again. Okay, so that's why I'm asking part by part. So this part is, if you have confusion in this part, the shear force equation in D to B and shear force equation between C to D. From D to B, it was W into X. I have placed the boundary condition at X equals to 0 and at X equals to 1. Why X equals to 0? It starts with 0 and it is ending at D is 1 meter distance, it is ending at N. So this part is over. Now when I consider a section here where I have a point load and UDL. This point load is 1 meter at distance. I am considering a section at X. So my shear force equation becomes W into X plus 5 due to this point load. Till this part is clear. Now what will be the boundary condition for this equation? Tell me. What will the boundary condition? What will the two values of X? Tell me. Write in the chat box. What will be the boundary condition for this equation? And have you understood this part? The shear force equation of Wx plus 5. Any confusion in this part? How I got this Wx plus 5? Hope this part is clear. Okay. So let's move. So the boundary condition at x equals to 1, boundary condition will be 1 and 1.5. This is 1, this is 0.5. So 1.5 meter. Boundary condition will be 1 meter and 1.5. So replace the value of x with this 7 kilonewton, 8 kilonewton. Okay. Now when I consider a section here between A to C, suppose I am taking a section here, it will be W into X plus this 5 plus this 1. Right? So this will be my shear force equation for this part. Wx plus 5 plus 4. So this is the equation. Okay. So for this boundary condition will be, this is the starting point. So here 1 plus 0.5, it will be 1.5 plus 0.5, it will be 2. So 1.5 and 2 will be boundary condition. So place the value of x here. You will get the FC and FA. Okay, 12 and 13. So this is the, so from all this value, this with different boundary, with different, suppose at x equals to 2 your shear force is 3 kilonewton. So at x equals to 2, draw the 13 kilonewton, and at x equals to 1.5 your is 12. So like that you draw the shear force diagram with different values. Okay. Then let's move to the bending moment diagram. So let's start with the bending moment diagram from here. The bending moment equation is here Wx due to the UDL. Wx, this is the force. Our moment is what? Force into distance. Right? So Wx is a force. Distance for the UDL we always take x, this the total distance by 2. It's x by 2. So it will be Wx into x by 2. Okay. Then next will be Wx square by 2. Same equation, but there will be add on of 5x minus 1 to 4x minus 5 due to this load. 5x minus 1, 4x minus 1 will be 1. So place the value of x at x equals to 1.5 meter and at x equals to 2 meter. We will get the moment also. Place the moment, we will get the new bending moment. Okay. Now again one cantilever beam is given. Now your UDL is spanning over a span of 1.8 meter. Okay. So try to find out the shear force and bending moment diagram for this beam. Only one load is applied. Right? Only one load is applied. 60 kilonewton per meter. 0.7. The span of UDL is 1.8 meter, and here from 0 in the 0.7 meter there is no load, and the beam is cantilever beam. So try to solve by yourself. Try. Able to do. So let's see. See, in this constant portion there is no load, so shear force will be same, and movement will also, the shear force will be same. So for just consider two sections. One section between here, between C to B, and one section between A to C. Okay, two section will be enough. So let's consider a section at a distance x from B. So I'm considering a section x. I'm considering section x dash at a distance x from the B. Okay. For that, the shear force will be W into x. Raise the boundary condition, we'll get the shear force. Since there is no load between point A and C, for the region Fx remains constant. Therefore, so see, I have found out the equation W into x. So this is the W into x for the medial portion. So now shear force will be same for this part, as there is no any particular load. Okay. Now SFD will be triangular between from B to C and a rectangle from C to A. Now with the bending moment, W into x into x by 2. Place the boundary condition, we will get the values. Now from C to A, it will be W into 1.8 into x minus 1.8 by 2. Place the boundary condition, you will get the bending moment diagram. The bending moment diagram for this condition is this one. I'll share the PDF, so you please go through this equation. I already shared yesterday, so please go through this PDFs. Okay, for the clear doubts. Now let's see the new beams. Lastly, we discussed cantilever beam. Okay, in that beam we have not found out the reactions. Now for this beam, this simple supported beam with complete UDL, it is supported at A and B, and this part is overhang. Okay, and we need to find shear force and bending moment. For this section also, you can take two sections over the this overhanging part. You can take one section, and you can take a section between A and B. Okay. Selection of section is very important when you start finding out the shear force and bending moment diagram of these beams. Okay. First, select what section and how many number of sections you will consider. That depends on your boundary conditions also. By taking moment of all the forces about point A, I got this is the equation RB into 3. This RB into 3. Okay. And due to this W, it will be UDL W by 2 into 4 square. This distance. It is acting at the whole distance. So it will be 4 by 2 WL square equals to 0. So I got RB as 8.3. And now from the static equilibrium, that is a summation of all the vertical forces will be equals to 0. So RA, as these are in upward direction, so RA plus RB equals to W into 1. This W is 1 into 4. So 1 into 4. So I got my RA. So my RA is 4.3, RB is 8.3. After finding out the reaction, let's start finding out the shear force. So at x equals to 0, that means from here, there is no, or let's consider this as C point. Let's consider this one as C point. Okay, as there is no support, so shear force will be 0. Yeah. So at FC, shear force is 0. At x equals to 1, FB just right, it will be W into x. So W is 1, distance is 1 meter, so it will be 1. And at x equals to 4 meter, my FA shear force is 4 minus RB. That means 1 into 4, this will be like this. W is 1, distance is 4 minus RB. Okay, so this became 4 minus, and my RB is 8 by 3. So I got FA is 1.3 kilo. The shear force will become 0 at x equals to 2.6. The maximum bending moment occurs at a point. You can also find out a distance on the beam where your bending moment, maximum bending moment. Okay, so when you equate the equation with respect to x equals to 0, you will get a distance where you will get the maximum bending moment over the whole beam. So this is the position x equals to 8.3 from end C, where your bending moment will be maximum. And this point is also called as contraflexion, point of contraflexion. This is a point of, this is where your bending moment, you can say where your bending moment changes the sign, or also you can say where your bending moment becomes 0. Okay. Next. See. So this simply supported beam has experienced a combination of load of UDL point load. So we can consider many sections. Okay, 1, 2, 3, 4, and 5. Right here, total will be 5 sections. In the first section, only RB will come. In the second section, RB and 8 kilonewton will come. In the third section, RB, 8 and this UDL will come. And in this section, whole UDL, RB and point load will come. And from this, for this section, you will get RB, 8, this UDL and this point load also. Okay. So this will be the shape of your shear force diagram, and this will be the shape of your parabolic. So whenever you have your load as UDL, whenever the load will be given as UDL, you will experience a parabolic bending moment. Okay. So please go through this PDF, how they have first found out the reactions from static equilibrium of equations. Okay, they found out the different reactions. Then they have found out the shear force at different points. Okay, at different points they have found out the shear force. And once after finding the values of the shear force at different points, at A, at C, at D, at E, F, B. So at every point they have found out the shear force, and they have joined by a line. The same way, find out the moment at every position. First, find out the moment equation, place the value of, use the boundary condition to find out the bending moment at that particular point and draw the bending moment. Okay. And for the maximum bending moment, you can derive the bending equations with respect to x. You will get the distance where at x, you will get the distance where your bending moment will be maximum over the whole span. So here I got at x equal to 5 meter, my bending moment is maximum, which is of 24 kilonewton meter. So till here, till question number 4, thoroughly practice this questions. Okay. Yesterday I shared the files also, all the PDF. If this PDF is important, I have shared the PDF of column and strut numericals. To go through that numerical, solve these 4 problems, it will be more than enough for shear force and bending moment. Okay. Last class we discussed cantilever with one particular load, simply supported with one particular load. Now today we have discussed cantilever and simply supported with combination of loads of UTL and point. Okay. Please write your roll numbers in the chat box. Any confusion you can type in the chat box. I'm not sharing my screen anymore, so you can type in the chat box if you have any issues, any confusion. You can type your roll number in the chat box. Anyone left to write their roll number? Please write your roll number. Those who have left. Anyone left? Last was report stream. Anyone left to write? Neha, Kishan, Ritoli. Anyone left? Big person. Please try to solve all those numericals I've shared today, okay? Since I've discussed today, I've shared already the files in the group. Please go through those files. Anyone left? Hope everyone wrote their roll number. Okay. See you in the next class. Thank you.